Hi, good morning, guys. Welcome to this channel again. This is Soft Code Math channel. I'm Ridwan. So today we are talking about laws of indices. Although we have already started, so this is part three. In part one, we talked about the laws of indices. Part two, we simplify some expressions. So in this tutorial now, today we'll be solving so many exponential equations. So we are going to start with all this. Can we see all the questions? I have five questions here, and the fifth one, can you see? I have already demarcated that. That means that is a very beautiful gift for you today. Okay, that's good. So without further ado, let's start. What we actually want to do is that we are going to solve all these equations by implementing some of the laws that we have discussed in the past. So if you have not watched, please kindly subscribe, share, and like. If you have not seen that of the previous videos, so you can check my channel, so you can check. So you will see the link to all those videos so that you can watch them. It will be very good because this one will serve as those one they serve as prerequisite to this one so that you will understand it far better. So without further ado, everyone, let's go. So let's start with the first question. We have to solve all this. Let's say solution. So the first one now, we have to solve anytime we are asked to solve a particular equation. What they are telling you is that from that equation, let me write this equation, 4 raised to power 2x, okay, equal to 2 raised to power what? 6x minus 1. The first thing is you have to check what is the unknown in that equation. The unknown in this equation is what? X. Now, what is the meaning of you solving the equation? What does that imply? That is, can you find the value of x, this unknown, in this equation which will satisfy this equation? So, in order to do that, the value of x satisfy this equation means that whatever the value you get at the end of the day, if you substitute in the left hand side and you substitute it at the right hand side, when you simplify after the substitution and you simplify this second one too after the substitution, you must have the same result. That is the meaning of the value of x that satisfy the equation. So let's go through this. Now, as you can all see, I have 2 raised to power something here. Look at this 4. Can I express 4 as 2 raised to power something? Of course, which is very possible. Why do I want to do that? Because I want to make use of, don't forget, we want to use some of those laws. So I want to do it in such a way that I will have 2 raised to power of something, so that since I'm having 2 raised to power something here, and that's the lowest value there. So I can now say that 4 can be written as 2 raised to power 2, then into 2x. Don't forget, this 2x is there, equal to 2 raised to power what? 6x minus 1. Am I communicating? Then from here, I have 2 raised to power what? 2 times 2x, that is what? 4x. From one of those laws, okay? Equal to what? 2 raised to power 6x minus 1. Beautiful. Now, if you remember, I think that is the last law. We said that whenever we have the same base in the left and the right hand side, then the powers are equal. Since the bases are equal, this one, they are equal. Therefore, their powers also are equal. We now say, therefore, from here, 4x is equal to 6x minus 1. Wow, beautiful. Now from here, what can I do? Here, we can do it any way we like. If I like, I can transform minus 1 to this place and take 4x to that place. It is very possible. But in order not to allow everyone to be confused, I can also say that, okay, what if I bring minus 1 to this place? Okay, I will now have 4x. When minus 1 get to this place, it become plus 1 equal to what? 6x. That means I'm having only 6x in the right hand side. Then after that, what can I say? I can also say, okay, I can transfer 4x to that side. 1 will be in this side. It will now become 6x. When you transfer 4x to this side, it will become minus. It will now be minus 4x. I will now have 1 is equal to what? 6x minus 4x. That is what? 2x. Please, I want us to know that I can, when you say 1 is 2x, I can also write it as 2x is equal to 1. The same thing. That is an equation. Left hand side is equal to right hand side. That means right hand side is equal to what? Left hand side. Good. Now, from here, now I want to get the value of x. Since I have multiplication in between 2 and x, I can divide both sides by 2. I can just say divide both sides by what? By 2. Okay. Then what will I have? 2x is equal to 1. So 2x is equal to 1. I will now have divided by 2 divided by 2. 2 will cancel 2 here. Therefore, x is equal to 1 over 2. Beautiful. Can you see that? Although we don't have time to be checking, but let's say we want to check one of them, like this first equation. I can try. If I want to check, what will I do? I will just put 1 over 2 at the left hand side. That is, x is 1 over 2. Put it here. It will now be 4 raised to power 2 times x. Don't forget, this is 2 times x. 2 times 1 all over 2. So 2 cancel 2, right? The answer is 4. That is for the left hand side. What of the right hand side? Let's check. This is 2 raised to power what? This is 2 raised to power 6x minus 1. That means this is 2 raised to power 6 times 1 all over 2 minus 1. That is 2 raised to power what? 6 times 1 over 2. That's 2 here. 2 here. That's 3. 3 minus 1. That is 2 raised to power what? 2. That is what? 4. Can you see? The left hand side gives us 4. The right hand side gives us 4. That is for when x is equal to what? When x is equal to 1 over 2. Therefore, that value of x satisfy this equation. Okay? Beautiful. That is that about that. Let's go for the next one, b. b now, that is 5 raised to power 1 over x is equal to what? 5 raised to power 1 all over x equal to 1 all over 1 to 5. Okay? Now, let's look at this. How do we solve this? Of course, we have to find a way to simplify the one at the right hand side so that we can express it as 5 raised to power something. Why? Because I am having 5 raised to power something here. I will now say 5 raised to power 1 over x can be written as 1 all over. This 125 can be written as 5 raised to power 3. Why? Because 5 raised to power 3 means what? 5 times 5 times 5. 5 times 5, 25. 25 times 5. That's what? 1, 2, what? 1, 2, 5. Okay? Now, I can now say 5 raised to power 1 all over x equal to what? You remember, one of those laws of indices, okay? I can write this one as 5 raised to power what? Minus 3. That means when you have 1 over 5 raised to power 3, I can write it as 5 raised to power minus 3. Remember one of the laws, which means when you have a raised to power minus 1, you can write it as 1 all over a. That means you can transform this one to this one. Similarly, or vice versa, you can transform this one to this one. Am I communicating? Aha. So that is what we are saying here. Therefore, now the bases are equal. What does that mean? Therefore, 1 all over x equal to minus 3. This is just like minus 3 all over what? 1. What can I do? Cross multiply. Please don't use this cross. We don't do that. Just write cross what? Cross multiply. X times minus 3. That's minus 3x equal to what? 1 times 1. That is what? 1. X times minus 3 minus 3x. 1 times 1. Then here, what we do? Divide both sides by what? By minus 3. What we now have? Minus 3x divided by minus 3 equal to 1 divided by minus 3. Okay? Divided by minus 3. So therefore, from here, what will be the result? Finally, I will now have what? Therefore, x will now be, therefore, minus 3, we cancel minus 3 here. X will now become minus 1 over 3. Beautiful. That is the B part. Now let's go for C part. Still now, we have what? 8 raised to power what? 1 minus 2x equal to what? 1 all over 4 raised to power what? X. Now, beautiful. I can write it as 8 raised to power 1 minus 2x equal to what? 4 raised to power minus x. One of the laws. We know what we are doing like that. But look at this. Of course, 4 is the simplest one. But can I express 4? Can I express 8 as 4 raised to power something? No. 4 raised to power 1 is 4. 4 raised to power 2, that's 16. It's more than 8. But what can I do? What if I reduce this one to 2 raised to power something? And I reduce this one to 2 raised to power something. Since it is possible, that's very good. I will now say, okay, this one is 2 raised to power what? 3. 8 will give me 2x over 3. But don't forget we have 1 minus 2x before. That's 1 minus 2x. Okay, so that this 3 will multiply by each term in this bracket. Equal to what? 2x to power 2 into bracket minus x. Don't forget, okay? Then what do you have? 2x to power 3 times 1, that's 3. Minus 3 times, that's minus 6x. Okay, equal to 2x to power minus 2x. Wow, that's beautiful. Now, the bases are equal as usual. What does that mean? Therefore, 3 minus what? 6x equal to minus 2x. Very beautiful. What can I do? Of course, I can say that 3, I can transform minus 2x to this side. Or you can say 3 is equal to, you can do it any way you like, minus 2x. And transform minus 6x to go and make minus 2x plus 6x. That is when minus 6x get to this side to become plus 6x. What will be the result? 3 is equal to what? Minus 2x plus 6x, that is what? 4x. Beautiful. Minus 2 plus 6, that's what? Plus 4. Therefore, since 3 is equal to 4x, don't forget, that means 4x is equal to 3. I can write it as that, isn't it? Good. Now, if I can write it as that, what will now happen, everybody? So, what will happen now? I can just say, okay, 4x equal to 3. How will I get x? Divide both sides by what? The coefficient of x. 4 is the coefficient of x. So, divide both sides by 4. So, divide both sides, okay, by what? By 4. What will I have? 4x is 3. 4x over 4 equal to 3 all over 4. 4 will cancel 4. X will now become 3 all over what? 4. Finally, the last one, so that this E part, you are the one that will solve that as an exercise. You can post it, okay? So you can just try it and tell me what you have. So we are going to stop here. Then this one is for you. That's my gift for you today. So the last one, 4 is by what? 4 is power of 2x, okay? Divided by 4 is by what? 3x equal to what? 2. Beautiful. What can I do? Very simple. We can use, you got it. I can pick one of these 4. One of those laws, you know, that was, I think that was loss 2. Raised to power 2x minus, because we have division, minus what? 3x. That means I have 4 raised to power something, I have 4 raised to power something. I will pick one of them. Then 2x, this one power minus this, equal to what? 2. Are you with me? Good. Now, I have 2 raised to power 1 here. I can express 4 also as 2 raised to power something. So now be 2 raised to power 2 into bracket 2x minus 3x. Are you with me? What do I have? Okay, what are we even doing? Okay, 2x minus 3x. What will it give us? Somebody? 2 minus 3. That's what? That's minus 1. So we can just say 4 raised to power what? 2x minus 3. That's minus x. Equal to what? 2 raised to power of 1. I can express this one as 2 raised to power what? 2 into bracket minus x equal to 2 raised to power of what? 1. Don't forget this power 1. Then I can now say that 2 raised to power 2 times minus x, that's minus 2x equal to what? 2 raised to power of 1. Bases are equal, therefore minus 2x equal to what? 1. That is, since the bases are equal, the power are equal. So from here, if I divide both sides by minus 2, therefore from here, x will be equal to minus 1 all over 2. Beautiful, everyone. Lovely. Wow, this is beautiful. This is cool. So, try this one, okay? Please kindly share, subscribe to my channel so that when I upload more on this, because in the next video, we still solve more questions under this before we say we are going to the next topic. Thank you. See you. Bye.